Hello, everyone, and welcome back. My name is Mr. Koval, and in this video, I'm going to be talking about molar mass. So, what is molar mass? Well, to review, in a previous video, I talked about the mole and that the mole is the chemist's dozen. And what the mole refers to is the number of particles in exactly 12 grams of C12. And that number is Avogadro's number, 6.022 times 10 to the 23rd of particles, right? So when we talk about molar mass, we're talking about mass in terms of moles, or the mass of 1 mole of a substance. So the mass in grams of 1 mole of a substance is the molar mass of that substance. So that's why we call it molar mass. So mass in grams of 1 mole. So what does that give us? So if we remind ourselves of the atomic masses, these are the masses that you find on the periodic table. You go to the periodic table, it's usually the number that's below the atomic symbol or the element symbol that's on there. And so, for example, you have carbon. Carbon has an atomic mass of 12.011 AMU. AMU is the atomic mass unit. This is the unit that we use to refer to the masses of very small particles like atoms and molecules. So here we're talking about the mass of exactly like one carbon atom. So one carbon atom would have 12.011 AMU approximately, right? So again, the atomic mass is a weighted average of all the natural isotopes of that particular element. So in carbon, we have carbon 12, carbon 13, carbon 14. And so this is a weighted average of those naturally occurring isotopes of carbon. So 12.011 AMUs is roughly the average mass of a carbon atom. Okay, same with hydrogen. That would be 1.008 AMUs, and oxygen would be 16.00 AMUs, and aluminum would be 26.98 AMUs. Now, and this is the atomic mass. So, what is the molar mass? Well, the molar mass is going to be based on 1 mole of the substance. And so, remember, the mole, the number of particles, is based on carbon 12. And so, when we look at the molar masses, everything is relative to carbon. And so it's not surprising, therefore, that when we have 1 mole of the substance, say, for example, carbon, then that mass of carbon is exactly the same number. So 12.011 grams of carbon is exactly equal to 1 mole of carbon. And so 1 mole of carbon, again, is 6.022 times 10 to the 23rd carbon atoms. So if I go to my balance and I mass out 12.011 grams of pure carbon, then that would be 1 mole, and I would have 6.022 times 23rd carbon atoms on the scale. So for hydrogen, it would be 1.008 grams of hydrogen. That's going to be equal to 1 mole. So that's the molar mass of hydrogen. So 1.08 or 1.008 grams of hydrogen. That would be equal to 1 mole of hydrogen. And so that's the same number of hydrogen. So Avogadro's number, 6.022 times 10 to the 23rd hydrogen atoms. Again, the atomic mass of oxygen is 16.00. The molar mass of oxygen is 16.00 grams of oxygen. And so 16.00 grams of oxygen is going to be equal to 1 mole of oxygen, which is again equal to 6.022 times 10 to the 23rd oxygen atoms. And the same thing for aluminum. So the key thing to notice here is that the atomic masses on your periodic table are equal to the molar masses that we would use in grams, right? So you can use your periodic table to find the molar masses of your substances. And this works out. The reason this works out is because uh, the atomic mass unit, these masses are relative to carbon. Since we chose carbon as the standard, which we're going to base the mole on, then all the other masses of the elements are relative to that. So hydrogen is 1.008. Hydrogen is 1/12 the size or mass of carbon. So when we look at the ratio, we get 1.008 in comparison to carbon. So it's all based on choosing carbon as the standard. And because of that, and then the mole is related to that as well, it turns out, it works out so that the number, the atomic mass, in atomic mass units for one atom of that element is the exact same number in grams for 1 mole of that element. And so you can use the periodic table to calculate the molar mass or look up the molar mass of the elements, and you can calculate the molar mass of any substance. So for example, right, if I wanted to find the molar mass of water, then all I do is I look up the molar mass of hydrogen, and I have 2 hydrogens in my water. I add those together. So I would add 1.008 twice. And then I have 1 oxygen, so I would add that to 16. And then I would get approximately 18 grams, or 18.016 grams is the mass of 1 mole of water. So as long as I can look up the atomic masses on my periodic table, I can calculate the molar mass of any substance that's given to me, as long as I know what the formula of that substance is. And that, ladies and gentlemen, is molar mass and how you calculate it. I hope this video was interesting and helpful. If you enjoyed this video, then please like, share, subscribe, hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have any suggestions about future videos, put them down as well. Thanks for joining me, and have a great day.